Good evening, this is Caitlin Garzone. This is my ePort 1 presentation. Okay, here is my microprocessor, and what we're going to be doing is subtracting 8 minus 3. So, first up, go over here to ROM 0, ROM 1. We're going to be setting these equal to their respective values. ROM 0, I'm going to set that equal to 8 in binary, that is 1, 0, 0, 0. Here at ROM 1, it's going to be set equal to 3, which is 0, 0, 1, 1 in binary. Awesome. Okay, so up next, up here in the northwestern part of our canvas, we have these 3 pins. We have clock, read, and write. Clock we'll be using later on when we're setting up our binary numbers up in these registers. Read, I'm going to go ahead and increment that, turn that 1 onto 1 right now. Here we go. So read is going to read the values 8 and 3 in ROM 0 and ROM 1 and send it right on up over so then we can get the output in store B. Write, this is something we'll be using later on, and make sure that's set equal to 0 as well as the accumulator output, which is over here on the east side. Write is going to be used when we send the final output right from over here to its final destination. But anyways, head it back west on the canvas, go to this address pin right here. So we're going to send ROM 1 value 3 over first. So the address 1, which is 001. Earlier, when I was first doing this, I did 100 and sent over a question mark up to store B instead of number 3 like I wanted it to. So that was a little interesting thing that let me know that I was doing it wrong. But anyways, after setting up address equals 1, switch this pin right here, A or B, on, then back off to 0. The data that was just read and sent over to this pin is going to be sent over to store B in this register. This register holds that number, the binary numbers for us. Okay, now go right here next door to E and B, set that equal to 1, and then we're going to go back here to the northwest with the 3 pins. We'll be using the clock now to send over the numbers, so turn that on, then back off. Perfect. No question mark, and certainly no variable D in here, which has happened before. So that is exactly what I want. Now, turn E and B pin back off, set it equal to 0. And now we're going to send the next value, ROM 0, value 8, up to the ALU. And the output's going to be 5 by the end of these next couple of steps. By going back west, set the address back equal to 0. Here we are. And then flip the A or B switch back on so that 8 is en route to the ALU. There we go. Then we'll head over here to the ENACC, right here to the right of the ALU, on the left of the accumulator register, and set that equal to 1. Turn the clock on and off. Perfect, that worked. Okay, here we are. We see the other value of 5, which is what we want. Okay, set ENCC back equal to 0. Be sure ENB is equal to 0. Turn that off as well. Actually, I'll keep that on because this number here, that's 5 in binary. So I'll keep that up right here. AC accumulator output, turn that on. Okay, and I know it looks wrong, it's ugly, it's scary, but they're off looking, that's for sure, but everything's fine. This just means that there is a buffer that is occurring because there are these 2 registers that are active, they have access to the data bus. So it's just a buffer. Okay, and now headed back northwest, set read equal to 0 because we're done reading the input values, the numbers from ROM 0, ROM 1. Awesome. Okay. And then we're gonna go ahead and send over the value of 5 up here to RAM 6. RAM, you don't touch these, you don't override these. Here we are. So set write equal to 1, because now we're going to be going ahead and writing and not editing, just writing it over. Set the address equal to 6, which is 110. Turn the clock on and off for the last time. Seemingly last time. Oh! It was the last time. RAM 6 now has a value of 5. That is how my microprocessor worked. Thank you so much for listening. And I do have to say that this was a great study method. I spent a lot more time on it than I probably should have, because everything in computer science is logic-based, and that is not something I had while doing this project. But it really did help at the end, so thank you.